So this lesson today is on polynomials and the graphs of the polynomials. And some of this stuff, was things that we had not really, I don't know if they were ever taught to me or not, but they were things that I definitely picked up on as I work more graphing problems, because you'll pick up on some stuff as you go through. But it, at the same time, does not hurt for you to see in a lesson type form, though you may be able to pick up on some of this stuff on your own. First thing we want to talk about is the end behavior of graphs. The end behavior of graphs. So the first thing says that if the leading coefficient, okay, you'll start off with that term leading coefficient. What does leading coefficient imply? What makes something a leading coefficient? It's the first term, right? And it's going to be, as far as polynomial equations are concerned, it's going to be the first term if the equation's written in descending order. In other words, exponents drop down from one term to the next. So if the leading coefficient is on an odd-degreed polynomial function, so what is a degree of a polynomial function? What is the degree of a polynomial function? Say that again?
Is that the exponent?
It is the highest exponent that is in the polynomial function. So, got the leading coefficient of an odd degree polynomial. If it is positive, if that value is positive, the graph is going to start low and end high. And here's an example of it. I draw a graph that starts here and it works its way up. It could go straight across or it could bend, whatever, but it's starting low and it's ending high. So that is an example of an odd-degree polynomial function with a positive leading coefficient. If the leading coefficient on an odd-degree polynomial is negative, if the leading coefficient on an odd-degree polynomial is negative, the graph starts high and ends low. So again, this is the end behavior. I draw an example, arrows going up, which indicates that it starts up here and it comes down and then it ends low. So we have the leading coefficient on an odd degree polynomial is positive. It starts low, ends high, starts high and ends low if that leading coefficient is negative. Now, one thing to take note of that's going to be different from odd degree polynomials and even degree polynomials is the range of odd degree polynomials is all real numbers. The range on even degree polynomials will not be all real numbers. I know a lot of people are going to be watching this viral video at home. There's a pause right now, so I guess on YouTube it'd be a good time for them to put in an advertisement. We can think of some stuff to advertise for. Let's advertise Expo markers. These are the best markers that you can buy for wide erase boards. And this is Expo markers. Thank you to our sponsor, Expo markers. I'm actually gonna connect them on this. And
You gonna put them on?
yeah, see if, oh, maybe we need to give to this. And then they'll realize that 5 people view it. So, anyway. I did that one time. I can't remember, I had a Sprite that was just sitting on the ledge of that other board over there when I recorded a lesson at the end. I said that it was by Sprite, and so I closed them in it, and or I added them, or whatever you call it. I'm not up on all that fancy schmancy terminology. I never got any money from them. I think it was Sprite. It may have been someone different. I think it was Sprite. It was some soft drink, and I usually drink Sprite, so. You know who else I could copy?
Who?
Gucci.
Gucci.
Yeah.
Okay. You seen the merch that they've been putting out recently?
Say that again?
You seen the merch that they've been putting out recently?
Uh-uh. Is it Gucci?
Always Gucci.
That's always Gucci. All right. Man. Now the 5 viewers who started viewing this are down to 1. All right, it looks like we can keep going. Okay, so next we have a situation where if the leading coefficient on an even degree polynomial function is positive, then that means the graph starts high and ends high. So very common even degree polynomial to consider is just y equals x squared. That is a parabola, right? And because, what did you learn in the past? If this leading term, which is of course the leading coefficient, if it's positive it opens up, if it's negative it opens down, right? Well that's the same thing as me saying, hey, it starts high and it ends high. So that's nothing new, just a different way of phrasing it. So if the leading coefficient on an even degree polynomial function is positive, the graph starts high and it ends high. And again, I didn't give specific names to these equations here, but I wanted to give one to this one just so you could start seeing a little bit of the application behind it and see that, yes, this does apply for actual equations. If the leading coefficient of an even degree, wow, I need to work on my handwriting, because I've been neat all year. Watching that. If the leading coefficient of an even degree polynomial is negative, the graph starts low and it ends low. And again, think back at x squared. If it was negative x squared, what did that graph do? It opened down, right? And open down just means you start low and end low. Well, it works for any even degree polynomial, not just negative x squared. So it's that leading coefficient. And again, it's the leading coefficient and it's the degree of the polynomial. So we'll be looking at those things to start. Where we're going with this is we're going to look at sketching graphs in the end. Now there's one other thing that's going to help us in sketching graphs, and that's finding the roots of the graphs. And a root of a graph, or also known as a solution, also known as a zero, the root of a graph is just what the x-intercept would be. Now, we'll see some of these x-intercepts we'll cross the graph at, and some of these x-intercepts we won't. So let's look at how we know what's happening at our x-intercepts. And this is called the multiplicity. Now, a lot of times when I do college algebra, it's about like a third of the students in the past have seen multiplicity before, and about 2/3 of the students are not familiar with this term. But it's not a difficult concept. It's just a matter of understanding what it is. So if you have a completely factored equation, and technically this is redundant, because if it's factored, it's completely factored. But I still like to put completely factored in there just to get the understanding that, yes, it's important that we factor it out. So if you have a completely factored equation, the exponent associated with each factor, the exponent associated with each factor is that factor's multiplicity. The exponent associated with each factor is that factor's multiplicity. So I wrote an example of a problem down that is completely factored. And its f of x is x times x minus 5 squared times x minus 1. Now, that x in front is as if it's associated with 0. So, this is like x minus 0 to the first power. So it has a multiplicity of 1. Then I have times x minus 5 squared. So that 5, it's an odd number, that doesn't matter. The only thing that matters is that exponent. And that exponent happens to be 2, which is even. And then we have x minus 1. Again, what's the multiplicity of that one? Starts with a W. 1. So it is an odd multiplicity. So how does that help us? Well, that helps us in that we know if a factor's multiplicity is odd, then the graph crosses the x-axis at that point, or at that corresponding root, I should say. So the root associated with x is 0. The root associated with x minus 5 would be what? How do we use a factor to find a root? How do we use a factor to find a root? In other words, if I have y equals x squared minus 3x plus 2, how does that factor? It's x minus 2 times x minus 1. So how do we use the factors to find a root? Or how do we use the factors to find the x-intercept? Set it equal to 0. Good. So we get that x equals
X equals
1 or 2.
yeah, 1 or
2, yeah, here, and x equals 1 here. So if you have x minus 5 squared as the factor, then what would the root be? What do you get when you said x minus 5 equal to 0? What is x? 5, yeah. So 5 would be the root here. What would be the root here for x minus 1? 1, yeah. So 0, 5, and 1 are the roots, or the solutions, or the zeros for this particular equation. All right, so if the factor's multiplicity is odd, then the graph crosses the x-axis at that corresponding point. And if a factor's multiplicity is even, then the graph touches the x-axis and turns away at that corresponding root. If a factor's multiplicity is even, then the graph touches the x-axis and turns away at that point. And here's a great example. We have y equals x squared here, right? Well, isn't that the same thing as me saying x plus 0 squared? Are x squared and x plus 0 squared the same thing? Yeah. So this multiplicity is 2. 2 is an even multiplicity, so the graph touches the x-axis at that point and then turns away from it. And again, you knew what the graph of x squared looked like before this class period. All right, I'm going to shut this first video down, and then the next video is going to have example problems.